What's up, guys? This is Rex with TorchPrep, back again with test 2, number 19. So what I want you to do before I dive into the explanation for this problem, I want you to pause the video, get out the red book, go to test 219, read through the problem, then press play. Awesome, let's go. So what they've given you are 8 different equations, and they're asking you which 8? There's only 5. 5 different equations, and asking you which one of these is not a line. Now, I will say for those of you who know the definitions of what a line has to be, this could be incredibly fast. You can do it, you can see it immediately. This could be a very good survey question. For those of you who have trouble visualizing what these equations are, totally get it, I have that trouble too. I would say this would be more of a work question. So if you're struggling with this one, I would suggest visualizing this in 2 ways. Drawing a quick picture or using a graphing calculator to plot in these equations. But I'm going to go through each one and explain to you which one is not a line and which ones are. Now, a good definition of a line in an equation. A line has to be one of the following. A line has to be simply in the formula x equals something, y equals something, or more complexly, slope-intercept formula. And we all know this one from way back in the 7th or 8th grade, y equals mx plus b. These are the only equations that are of a line. You notice there's no exponent on our variables at all. They are all xy to the 1. They can have a slope, and they can have a y-intercept in this formula, or they can just be x and y equals. These are the only ways we can have a line. So let's go through each one, and I'm going to quickly draw it here and show you what it looks like, and to see, is it a line? So first one, in A, is x equals 4. So it's in this formula. What that basically means is, for all values of y, all the time, x equals 4. We go to x, on the x-axis 4, and we draw a perfectly vertical line to infinity, negative, and positive in the 1st and 4th quadrants. That is a line. It also fits the bill over here of one of our formulas for a line. What about this next one? I have 3y equals 6. Let's quickly solve that one. 3y equals 6. If I want to isolate y, I can divide both sides by 3, and y equals 2. Now, unlike these vertical lines, when y equals something, I will draw a horizontal line at that number. So for y equals 2, I'm going to draw a horizontal line through that place. Straight line fits one of our formulas. It's obviously a line when we draw it. Now, what about the next one? I have x minus y equals 1. Let's see if I can put that. I have x and y in here, so I can't use one of these first formulas for a line. I have to use slope-intercept formula. So what I'm going to do is I'm going to just move this around to look more like slope-intercept formula. I have x minus y equals 1. I'm going to subtract x from both sides. So if negative x over here, x's cancel out, I have a negative y equals 1 minus x. Now, if I want to get rid of that negative, I can divide both sides by negative 1. That is not what I meant to say. I can multiply both sides by negative 1. Sorry, y'all. Negative 1 on both sides is going to make that y positive. So then I have y equals, I have a negative 1 now and a positive x. I'm just going to flip them around. Positive x minus 1. Now, what does this look like? Slope-intercept formula. I know there's no number in front of the x, but think of the m as just an imaginary 1. That is slope-intercept formula. So if my slope is 1 and the y-intercept is here at negative 1, the line's going to look something like this, and you'll see that in your calculator. It does have a slope and a y-intercept. It has both variables involved, but it's still a line. So that one cannot be it. So we've already eliminated. We're trying to find which one isn't a line. A, B, and C are all lines. Let's check out D. What formula is this in? It also fits the bill right here. I see y equals something x plus or minus b. This is also in slope-intercept formula. That makes it a line. So it's going to meet the slope-intercept is b. the y-intercept is right there at -2, and it's going to have a slightly less extreme curve because it's not a slope of 1, it's a slope of 3/4. But again, we have a line. What about our last one? We have a square above the x. It is an exponent other than 1. Now, whenever you see an exponent there, you know that has to be some sort of a parabola. I'm just going to change it really fast for us. So instead of x squared, I'm going to put the y by itself, plus y equals 5. I'm going to subtract x squared from both sides, so it's going to be y equals negative x squared plus 5. So I know my intercept is way up here at 5, but it's a negative parabola. And parabolas are not single lines. They have this cool shape. So that in detail shows you all of these different ones are lines except for that. So now you know in the future, if it asks you, is this a line? If it has any exponent on a variable, it cannot be a line. It'll be a parabola or some more complex shape. Now that you know that, this question, you can zero in immediately, find the one that is not a line and move on the next time you take a practice test. Great job, and move on to the next question.